In this video, we're going to look at another technique for solving systems, and this technique is called substitution. And when we substitute, we put a value in the place for something else. For example, you substitute with formulas. If you have A is equal to BH, and somebody tells you that the base is 5 inches, and the height is 10 inches, you substitute those values in the place of their variables. So A would be 5 inches times 10 inches or 50 square inches. Now, we're not going to be doing it in a formula setting. We're going to be working with systems, and we're going to have things like 2x plus 3y is equal to 7, and I'm just making this up and I'm not going to solve it. Y is equal to 8x minus 3. When we use substitution as a technique for solving systems, one of our two equations needs to be in the format y equals or x equals. We're going to take that value and we're going to substitute it in the other equation in the place of that, so that we get, whoops, and I just touched something, so that we get 2x plus 3 parentheses 8x minus 3, because that's the value for y I've substituted, that's equal to 7. So that's just a little preview about what we're going to do. Let's look at some problems. The first problem, we have x is equal to 3y, I'm sorry, I miscopied that, x plus 3y is equal to 5, and x is equal to negative 2y. I call this system ready for substitution because one of the two equations is the form either x equals or y equals. This one says x equals negative 2y. So I'm going to substitute negative 2y in the place of x. That means that I'm going to have negative 2y plus 3y is equal to 5. Once I've done the substitution, that means that I'm only going to have one kind of variable in my equation. I have the algebra skills to solve that. I can simplify. Negative 2y and positive 3y gives me y is equal to 5, and it turns out I'm finished. Finish finding one of the unknowns. Now, find x. When you're using the substitution method, you can always go back to the equation where you have the circled expression, x is equal to negative 2y, write it down, take the value you got for y, put it in, x is equal to negative 2 times 5, x is equal to negative 10. So in this particular problem, we still have the scenarios that were obvious before, where we have either an ordered pair or we have infinite solutions or no solutions. So in this one, we have an ordered pair, so I would pick choice A. I have to write it as an ordered pair. The ordered pair, no matter what order you find them, x has to come first, so negative 10, comma 5, close parentheses. All right, let's take a look at our next problem. Still using substitution. I have the system, I'll just write down, I guess I'll do it here. X plus y is 20, and y equals negative 5x. I call, again, this system ready for substitution because I have an equation that says, in this case, y equals. In the last one, I had one that said x equals. It doesn't matter as long as one of them is ready. Now I will take that value and I'll plug it in the place of y because it is equal to y. So I'll make a little note that I'm substituting now. I have x plus, in the place of y, I put negative 5x, close, is equal to 20. And I solve that equation. So I have negative 4x is 20. Divide by negative 4. X is equal to negative 5. I'm halfway there. Now, find y. These problems have many steps or parts, and so I try to label them so that you can keep up with it. You can do this for yourself. Go back to the circled expression. Y is equal to negative 5x. Take the value you got for x. Y is equal to negative 5 times negative 5. That means y is equal to 25. All right, once again, I got an ordered pair. So I will choose A, and I get the ordered pair negative 5, comma, 25. Okay. All right, let's look at a few more examples. I have y is equal to 2x plus 1, and 5y minus 6x is equal to 13. Once again, I call the system ready for substitution because I have a y equals. I will take that and plug it in the place of y. So I will substitute. I have 5 parentheses. In the place of y, I put 2x plus 1, close, minus 6x is equal to 13. Distributive property, that gives me 10x plus 5 minus 6x is 13. Combining like terms, 4x plus 5 is equal to 13. Subtract 5 from both sides. 4x is 8. Divide by 4. And x is 2. Now I need to find the y value, so now find y. Once again, go up, grab the equation with the circled expression. Y is equal to 2x plus 1. Substitute. Y is equal to 2 times 2 plus 1. Y is equal to 4 plus 1, which is 5. My answer for the third time, I've gotten a ordered pair answer, and it is 2, 5. Before we finish, we will see examples of these other choices. Next one, I'm going to write down here, I have x plus 7y is equal to 18, and I have 2x plus 3y is equal to 3. For the very first time, this system is not ready. I do not have an x equals or a y equals. So I have to either solve for one of these variables, or I have to solve for one of these variables. You will find that it is easiest to solve for a variable whose coefficient is either an implied 1 or implied -1. So I'm going to solve for this x. I'm going to take this equation off to the side, and I have x plus 7y is 18. Subtract 7y, and I get x is equal to -7y plus 18. And you were welcome to have 18 minus 7y. It wouldn't matter. All right, I have a new system to look at now. Once again, I write little notes as I go along. I have x is equal to -7y plus 18, and I have 2x plus 3y is equal to 3. So I replaced this equation with its modified form, and I look at this as a new system. Now it is ready for substitution. I'm going to take this value for x. I'm going to put it in the place of x. So I'm going to substitute 2 parentheses negative 7y plus 18 close parentheses plus 3y is equal to 3. That gives me negative 14y plus 36, distributing the 2, plus 3y is equal to 3. Combine like terms, I have negative 11y plus 36 is equal to 3. Subtract 36 from both sides, and I have negative 11y is negative 33. That looks good, it's divisible. Y is positive 3. Unfortunately, I'm not all the way through. Now, we have y, so now find x. You should have an equation where it's circled. X is equal to negative 7y plus 18. I'm going to plug that in. X is equal to negative 7 times 3 plus 18. X is equal to negative 21 plus 18. X is equal to negative 3. So my answers are negative 3, positive 3. Going all the way back up here, I have the ordered pair, negative 3 for x, positive 3 for y. All right. We have quite a few examples. You have this many homework questions, and that's because you really do need some practice at this. All right, let me give myself much more workspace here. All right, I have 21x plus 7y is equal to 34, and negative 3x is equal to y plus 6. It's not ready. It would be easiest to get it ready by solving for this y. So that's what I'm going to do. And I'll make a little highlight so that you look at this and you know, oh, we're going to solve for this. The first thing I'd like to do, it is not necessary, but I'm going to turn it around as y plus 6 is equal to negative 3x, because I like what I'm solving for to be on the left sometimes. Subtract 6 from both sides, and I get y is equal to negative 3x minus 6. I have a new system. The new system is 21x plus 7y is 34, and y equals negative 3x minus 6. Now it's ready. That's the value for y. I'm going to plug it in the place of y. So I'm going to substitute now. I have 21x plus 7 parentheses, negative 3x minus 6, close, is equal to 34. Distributive property, keep the 21x. 7 times negative 3x is minus 21x. 7 times negative 6 is negative 42. That's equal to 34. When I combine like terms, my variables drop out and I end up with negative 42 is equal to 34. So I obviously cannot solve for an x or a y because they've dropped out. So I have to look at the leftover statement as an indicator to what's going on. Because this is a false statement, what that implies is that these two equations, which represent lines, cannot intersect, because they would intersect only whenever negative 42 is equal to 34, which is never. So when you get a false, that means there's no solution. Okay, that's the algebraic indicator of parallel lines. Let's look at another one. This time I have 5x plus y is equal to 22, and 9x plus 7y is equal to 24. As you look at it, can you see which variable looks the easiest to isolate? I hope you're looking at this y. So I'm going to take that. I have 5x plus y is 22. Subtract 5x, and y is negative 5x plus 22. I have a new system. Now I have the top equation has been rewritten as y equals negative 5x plus 22, and the second one is 9x plus 7y is 24. It is ready for me to substitute because this expression is equal to y. I can put it in the place of y. So I will substitute. I have 9x plus 7 parentheses, negative 5x plus 22 is equal to 24. I have 9x, distributive property. 7 times negative 5x is negative 35x. 7 times 22, 14, carry the 1, should be positive 154, and that's equal to 24. Combine like terms, I have negative 26x plus 154 is equal to 24. If you hear some noise, it's me grabbing my calculator. I'm going to subtract 154 from both sides. That gives me negative 26x is equal to negative 130. Divide by negative 26, and x is equal to 5. So that worked out nicely. You will not always get integers as answers, but these problems are a little bit rigged. It really helps with your confidence level when you do get an integer. So now find y. Go all the way back up. There is an easy equation. You could pick this one to find y. It would just be more work. So I have y is equal to negative 5x plus 22. Plug in. Y is equal to negative 5 times 5 plus 22. Y is equal to negative 25 plus 22. Y is equal to negative 3. My ordered pair is 5, negative 3. So I'm back to this. It is 5, negative 3. All right, one more problem. Let's see what we get. We have 1/4 x minus y is equal to 7, and x minus 4y is equal to 28. Well, if you want to use substitution, which of these 4 variable terms would be easiest to solve for? My opinion is that x. So I will take x minus 4y is equal to 28, and I'll add 4y to both sides. X is equal to 4y plus 28. I have a new system. I have 1/4 x minus y is equal to 7, and I have x is equal to 4y plus 28. It's ready for substitution, so I will take this expression for x and put it in the place of x. Substitute now. Have 1/4 parentheses 4y plus 28 minus y is equal to 7. Now, at first you might think, oh no, I have to work with fractions, but this problem has made it pretty friendly. 1/4 times 4, you go off to the side if you need to, put the 4 over 1, those divide out, and you get 1. This is 1y plus 1/4 times 28, put the 28 over 1, 4 goes in there once, 4 goes in there 7 times. I have plus 7 minus y is equal to 7. So it was not hard to take 1/4 of 4 and 1/4 of 28. Combining like terms, my y's cancel out. So I have 7 is equal to 7, which means I'm not going to find an ordered pair. This is a true statement. These two lines intersect anytime 7 is equal to 7. Well, 7's always equal to 7. That means that these are the same line, which means they intersect infinitely, so it's infinite solutions. And there are infinitely many solutions. So even though we never looked at a graph during this lesson on substitution, we still had either this scenario where you have an ordered pair, this scenario where you have no solution, or this scenario where the two lines are really the same line, infinitely many solutions. So we didn't have to see a graph to know what was going on. That's the second the second technique for solving systems. First was graphing, then substitution.